Welcome to this Forge College Explainer. I am super excited to have you back in our From EVM to SVM track. Specifically, we're continuing our journey through porting token standards, going from Ethereum's ERC20 and 721 over to Solana. If you remember our previous lesson on minting flows and transaction patterns, we basically learned how to pour the concrete, right? We initialized the mint and created those associated token accounts. But today, we're opening up the engineering blueprints once again to give your Solana tokens an actual inked identity. We'll be looking at metadata, NFTs, and some truly awesome token extensions. Let's dive right in. Okay, let's take a quick look at the agenda sketched out here. We've got 6 key areas. First, the naked token problem. Second, attaching metadata identity. Third, supercharging with Token-2022. Fourth, mutability and authority rules. Fifth, validating your devnet build. And finally, number 6, prepping for token transfers.
Let's kick things off with Section 1, the naked token problem.
So, in our last lesson, we built a token that was perfectly functional but completely invisible. A naked token. You did all the heavy lifting, setting up the mint authority, funding the accounts, which is fantastic, but right now, your token is practically a ghost. So I have to ask, what really is a token without metadata? Well, without a name, a ticker symbol, or an image attached, your token is just this boring string of alphanumeric characters experiencing a very sad identity crisis on the blockchain explorer. I mean, imagine showing up to a party, right? And instead of a name tag, you're just wearing a 44-character cryptographic hash. That is your token right now. The math works, but as humans, we have literally no idea what it represents.
To fix this, we're taking the 2-step foundation you already know. Step 1, initialize the mint. Step 2, create the associated token account, or ATA. Now we are bolting on Step 3, attaching the metadata account. Think of this as drafting the final spec sheet and painting the custom branding right onto the mechanical chassis you just built.
Which brings us seamlessly to Section 2, attaching metadata identity.
So how do we physically attach this identity plate to our tokens engine on Solana? Well, if you're coming over from the Ethereum EVM world, you're probably used to just stuffing the token URI right inside the smart contract state. But Solana does things a bit differently to keep everything incredibly fast and cheap. And this brings us to a brilliantly Solana native concept, the metadata PDA, or program-derived address. Instead of cramming all this heavy text and linked data directly into the mint account itself, we use a completely separate metadata PDA. It's basically a canonical account that is inextricably linked to your mint, and it holds all the human-facing identity stuff. This architectural choice is brilliant because it keeps the base mint incredibly compact, like a stripped-down, lightweight race car engine. Meanwhile, the PDA acts as a sidecar carrying all the luggage and the flashy branding.
Let's look at the technical spec sheet drawn out in this table here to see exactly what lives inside this PDA. First, you've got your readable name, something like Super Cool Ape. Then you've got your symbol, which is that short ticker identifier that wallets absolutely love. Crucially, you have the URI. This is a pointer to an off-chain JSON file, ideally hosted on something decentralized like Arweave, which then points to the actual image and the attributes of your NFT. And finally, you have the sellerFeeBasisPoints. This represents your marketplace royalty fees. Just as a quick refresher, 100 basis points equals exactly 1%. So if you want a 5% royalty, you're going to set this to 500. Simple as that.
All right, moving on to Section 3, supercharging with Token-2022.
Once you have that basic identity attached to your token, you definitely don't have to stop there. You can actually add these massive aftermarket turbo boosters using the Token-2022 family of extensions. And let me tell you, these extensions are absolute game changers. They fundamentally alter how your mint behaves at the protocol level. We're talking about powerful mechanics here. Things like transfer fees that trigger on every single transaction, custom default account states, highly programmable ownership rules. Unlike the traditional SPL tokens, these Token-2022 extensions literally change the storage layout of the mint itself to accommodate these complex, built-in behaviors natively on-chain.
Now, when you are actually building this out in your code, you basically have 2 main approaches to choose from. You can use the Metaplex SDK, which is absolutely amazing for fast bundled prototyping. It neatly wraps the minting and metadata creation up into a perfect little package. Or you can get your hands dirty with low-level instructions. Why would you do that? Well, writing low-level instructions gives you granular, manual control over the exact program-derived addresses and seeds. Honestly, if you really want to master Solana development, my advice is to use the SDK to prototype, but seriously study those low-level instructions to truly understand how the engine works under the hood.
Let's jump into Section 4, Mutability and Authority Rules.
Now you might be wondering, what happens if you want to alter your token's blueprint after it rolls off the assembly line? Can you just update the metadata whenever you feel like it? Well, that is a massive design choice you have to make right at the start. You've got to choose between mutable metadata and immutable metadata. Mutable metadata allows for controlled future updates. This is absolutely perfect if you have an evolving gaming asset where the character stats might change over time. On the flip side, immutable metadata creates a permanent, fixed on-chain pointer. Marketplaces and collectors absolutely love immutable metadata. Why? Because it guarantees the creator can't just suddenly swap out the Mona Lisa for a picture of a potato after they've made the sale.
So the crucial point is this: if you do choose mutability, who actually gets to make those changes? That brings us to the update authority. This is the specific cryptographic key pair that is explicitly allowed to modify a token's mutable metadata post-creation. This authority is deliberately enforced on the metadata account itself. If you hold this key, you hold the absolute power to change the token's identity. So it goes without saying, you must securely guard this update authority key pair with your life.
Okay, let's move into Section 5, Validating your DevNet build.
It is officially time to put on our hard hats, grab our clipboards, and act as safety inspectors for your DevNet build. Writing the code is only half the battle, right? Validating that it actually worked on-chain is where you truly level up as an engineer. You'll want to run down this exact pass and fail checklist to guarantee your blueprint actually executes correctly on the test network. First up, does the metadata PDA actually exist and decode properly? Second, when you fetch the metadata, does the URI precisely match your uploaded JSON endpoint? Third, if you're making an NFT, verify that the mint supply equals exactly 1 and your ATA balance is exactly 1. Fourth, let's test your security. An unauthorized update should outright fail, while an authorized one should succeed. And finally, double-check that the JSON at the end of your URI actually has the image and attributes properly formatted.
Now, what if something goes wrong? What if you see some red ink on that clipboard? If any check fails, do not panic. Just dig into the simulation logs using Simulate Transaction and check those RPC error codes. Usually, if something breaks here, you're either missing a signature, you're calculating the wrong PDA seeds, or maybe you're running into rent exemption errors. Adjusting your authority fields or just reordering your instructions will usually get you right back on track.
And lastly, Section 6, Prepping for Token Transfers.
Assuming your DevNet validation checks out perfectly, your token is now fully assembled, drafted, branded, and ready to be shipped out into the world. As we wrap up today's blueprints, I want you to always remember the golden rule of this architecture, quoted right here. Authority is deliberately enforced on the metadata account and governed by the authority you set at creation. That brilliant separation of the metadata into a PDA is exactly what keeps the basement lighting fast. But it also means that you, as the developer, are fully on the hook for rigorous, careful authority management.
So, make sure you keep your DevNet mint, your PDA, and your mutability notes easily available, because you are definitely going to need them for our upcoming lesson on transfer mechanics. This has been a Forge College Explainer. I highly encourage you to visit forge.college to dive deeper into this code and continue mastering your transition from EVM to SVM. But before you go, I want to leave you with one final slightly provocative thought to ponder. When you ship your token out into the wild, who really controls its destiny? Is it the user holding the coin in their wallet, or is it the developer holding the update authority keys? Think about that, and I'll see you in the next one.